Hey makers, thought it'd be fun to put together a video on creating 3D typographic light boxes using Fusion 360. Now this is not the only way to do this. There's a lot of great video resources out there. I have just found a process that seems to work well, starting with an SVG and bringing that into Fusion 360 and then doing some offsets and creating some extrusions and using tolerances to create pieces that can fit together. So what we'll do is we'll create a multi-piece assembly. You can print these in parts, then you can glue them together. And in this case, we'll create some cavities so you can run an LED strip throughout the entire typographic 3D object, and even a spot for a switch and how to run a cord. So let's dive in. All right. I'm going to get started in Adobe Illustrator. You don't have to do this in Illustrator, but what Illustrator is great at is creating vector artwork, which you can then output to an SVG format, which is what we want to use in Fusion 360. So here, I just have some basic text that I had typed in here. You can see it's still editable. And then what I do is, and this is necessary if you're going to be exporting this out to use in Fusion, is you have to flatten the text because it's still not in what is called vector format. It is still a kind of rendered text-based entity. So in Illustrator, the way that you do that is you go up to Object, and I know you can't see the menu, Object, expand, and then what that's going to do is it's going to create outlines, and that's what we want. If I click here, you can see now I can go into this like path and mess with it. So that's exactly what we want. So we're going to save this out to the desktop and then jump over to Fusion 360. So here we are in Fusion 360, and I'm not going to go over the entire Fusion 360 interface. There's a lot of videos out there that do a great job covering Fusion 360. This is going to really only show you the tools necessary to work with our imported SVG, do some extrusions and some simple organization, and then we might touch on user parameters. Okay, so once you're in Fusion 360, you should be in a new file. If not, you can go up and hit the plus button in the upper right corner that says New Design, or you can hit Command or Control N to create a new file. Some quick navigation tips. You can use your middle mouse button and drag, and that will pan around your environment. If you hit Shift and middle mouse button, you can orbit. And if you use your middle scroll wheel on your mouse, you can zoom in and zoom out. Or you can press Control Shift, middle mouse button, and drag, and it will allow you to zoom in and zoom out. I oftentimes use a Wacom tablet, so I don't have a mouse wheel, so I tend to use this method quite often. Another way to navigate is you can use this cube in the upper right corner. You can click and drag on it, and it will allow you to somewhat navigate your work environment. You can also click on the sides of the cube to go into orthogonal views, which is extremely helpful. And then you can hit the home button, and it will take you back to this kind of isometric view that we had when we first came into the tool. On the left-hand side, we have an outliner. This is going to keep track of all of our physical pieces of our file. That would be sketches and objects and components. And then on the bottom, we have the timeline. This is probably my favorite feature of Fusion 360, being that it's a parametric modeling tool. You can go back in time and easily make changes to your sketch that will then impact the resulting geometry. So unlike some tools where if you want to make changes to geometry, you kind of have to remodel it or physically make some changes to it. Here, if you are using sketches, you can simply update the sketch, which is really awesome. Okay, so the first thing I'm going to do here is I'm going to create a sketch. You got to make sure you're on the solid tab here. I hit create new sketch, and then it's going to ask me which origin plane I want this on. I want it on the front plane, and then I'm going to go and I'm going to get a 2-point rectangle, and over here in my palette I'm going to make it a center rectangle, and I'm going to make it a construction type. Construction lines are basically for reference only. You cannot use them to make extrusions, so these are used as kind of references only. And what I'm going to do here is I'm going to create the build plate volume for my 3D printer. I've got a Prusa and a Bambu, and I'm going to be printing these parts on both. So I'm going to use the smaller of the two, which is the Prusa, which is 256, I believe, by 210. Doesn't have to be perfect because I'm not going right up to the edge anyways. Hit the enter key, and there we go. And you'll notice that it's drawn these kind of lines with arrows at the end. These are called constraints, and this is constraining this box. So you notice if I try and like grab one of the sides and move it, I can't do it, and it's because it's being constrained by this numeric value here. And we're going to use these more as we start building our sketch, or I'm sorry, as we start building our file. So I'm going to say finish sketch. And now what we're going to do is we're going to import our SVG, or sorry, insert. So I'm going to go up to insert, insert SVG, insert from computer, and then there it is on my desktop, boom, SVG. And now it's going to ask me which origin plane I want this on. So I'm going to put it on the same plane that we did our initial reference sketch, which is the front plane. And there we go. You can see the SVG paths have been imported. It's pretty common for it to come in either backwards, upside down, or the orientation is just off. So you have these tools here that will let you swap horizontally and vertically. So I'm going to hit the vertical flip, and then you can also move it around by dragging the cube. And this little kind of like, I guess you could say like quarter circle, you can grab it and it will scale. So I'm going to scale mine up to right about here because, again, we're going to be printing this in pieces, and looks like I could fit roughly about 2 letters on the build plate at a time if I use this size. Also, something to be aware of when you're making these typographic light boxes is use a blocky font. You'll thank yourself because it's going to give you a lot more room to insert and run the LEDs and fit your hands inside of the recesses. If you're not going to illuminate it, no need to make it super huge. You don't have to also use as blocky of a text, but when it's for lighting purposes, making or using a blocky font is, like I said, you're really going to be thanking yourself. All right, so I'm going to kind of just align mine roughly here. It doesn't really matter at this point, but we'll just kind of put it right there. Okay. And so here we have our sketch. You'll notice that it's blue. That is good. That means that these are filled in paths that we could in fact extrude if we wanted to. So if I grab a hold of one of these, press the E key, you can see that I can extrude that and create a 3D body. Something else to be aware of. Let's say that you brought your sketch in and you wanted to move it or change the size of it. If I click on it, I can't seem to move it. And this is something that took me a little while to learn in Fusion 360. You'll notice on the left we have 2 sketches. So we have our initial sketch that we created for our build plate, and then we have our SVG sketch. They both have locks, and that is why this cannot be moved. This sketch is entirely locked, indicated by the green lines. So how do you unlock it? Good question. Okay, so we're going to go into sketch mode. You can do this one of 2 ways. You can right click on the sketch in your outliner. You can also double click on the timeline and it will take you into edit mode. You have to select the sketch that you want to manipulate and then hit the unlock key. Okay, so now you'll notice this is blue. And I press the escape key so that I'm not using the lock anymore. And if I select, let's just select the whole thing here. I still can't move it, there we go. I'm sorry. I was clicking in the wrong place. So now you can freely move this. And you can scale it by going into the shortcut menu by hitting S and then type in scale. And you see our scale option, and then it's going to ask us to scale around a point, which is, this gets a little more convoluted. And I was going to select the origin, but I can't because the sketch is right on top of it. But you get the idea. This is how you would go about, if you wanted to manipulate a sketch. When you're done, go back and lock it again and finish sketch. Okay, let's start making some offsets because we're going to need to create some additional lines to use for our geometry. So let's go look at a reference real quick. Here is a example of another light box that I made not long ago, and you'll notice that a couple things. Our frames, as I'm going to call them, have a little step here that you can see, and that is so that when we push our insert in, it will seat itself on this little ledge. And if we look at this over here, you can see here is one of the orange bodies that is fitting in nicely. And there's also a little gap that you can see right here between the frame and the insert, and that is a tolerance that is added there on purpose, because most printers, if you were to not add a tolerance or a slight gap, you won't be able to get these inserts to fit inside of the frames. It'll be way too tight. So you usually need to give about a 0.12, 0.14 millimeter tolerance. So we're going to need to add some lines to our sketch to achieve that. Okay, so first of all, I'm going to create a frame, and I'm going to use the O key, and that is going to put me into offset mode. Now, I haven't actually entered into sketch edit mode yet, and it knows that. Fusion's pretty smart. I just went and hit the O key, but if I click the B, you'll notice that now we're inside of our sketch mode, and the offset tool has already been selected for me, and I can just select a path, and here we go. This is how you offset these paths. I'm going to choose a value of 8 millimeters here, and you'll see here you've got a little constraint again indicating that we've offset this path, and that is great. That's going to work for our frame. We also need to do it to the negative area here, or the I think it's called a bowl. I can't remember. Typography is slipping my mind right now. But anyways, we're going to offset the inner piece as well. And the bottom one, if we try and do it here, it's going to get so small that it's almost not really worth doing. You could do it if you want or not. Basically, what's going to happen to this area will be hollow. So it's completely optional in some of these cases if you even want to go about hollowing out the negative space, and it'll make sense in a moment. Apologies when we start extruding things. Okay, so we're going to need 2 more offsets. We're going to need an offset so that we can create our kind of, let's call this like the edge of our insert, and then we're also going to need 1 more offset for the tolerance so that we have that little gap. So let's do the our edge. So we're going to hit the O key again, and we're going to start from this green line. So we're going to click on our green line, and I'm going to do 1.25. Okay, so we got 1 more line. Now, what we really want is we want a tolerance between where my cursor is right now and this line. But I can't click on this line and hit the O key. I can't offset from this. It's telling me that you've already done an offset. And that's because Fusion doesn't let you do offsets of offsets. So I can't go over here to this line that was offset 1.25 and then offset it again. I have to do it still from our green line. And basically what we want is we want 1.25 minus 0.12 or 0.14 roughly. So we can actually do math in line. So if I hit the O key, and we're going to go 1.25 minus 0.12. No, that's actually not what I wanted. I'm going to do Command Z. Let's try this again. So we're going to do 1.25 minus 0.12. I think that's what I had done before. I accidentally did 1.2, not 0.12. Okay, and that is 1.13. Great. So this is all of the offsets. Oh, you know what? I'm sorry. Actually, that's not. I spoke too soon. We need to do those same offsets to the inner pieces. So we're going to hit O for offset, 1.25. And then we now know we don't have to do math here. It's 1.13, so we're going to go 1.13. Great. Do the same thing down here. Offset, O key, 1.25. O key again, 1.13. Great. All right, now our B letter is ready to be extruded. So the first thing we're going to extrude is the whole entire piece, because we want to make the back. So we're going to have to zoom in here a bit to make sure that we're getting all these bits. And all I'm doing is I'm holding my shift key and I'm clicking in the spaces that are not blue. And as soon as you click them, they become blue, which means you've made a selection. And I'm going to tell you in a moment, there's more than one way to do an extrusion as far as the process you take. And I'm not going to select this little overlap right here. We're going to leave that. Okay, so now I'm going to hit E to extrude, and I'm going to hit 1 for 1 millimeter. And there we go. So now we have our first body, and a couple things happened. One, it hit our sketch, and that's just, Fusion just does that, so we're just going to turn it back on, and you'll notice now we have our first body. Okay, great. So as we're looking at this, and we'll get into this more, you might decide that, oh, I want to make my, I want to make my frame bigger. And it's very easy to do that because of parametric modeling. So what we can do is we can go back into our sketch. Instead of 8 millimeters right here, we could change this to 10. Okay, and now we're going to hit Finish Sketch. And look at that, our body updated. If I hit Command Z, you can see there. Let me go back one more. Okay, we can see how thick it is. Let's jump forward, and now you can see it's gotten wider. This is where parametric modeling is extremely powerful. So I'm going to go back to 8 millimeters, and I'll hit Finish Sketch. Okay, next let's do, we need to extrude our frame. We haven't done that yet, so let's extrude the frame. So we're going to select the thick parts of our offsets here. And once again, we'll hit the E key, and we're going to do a depth of 40 millimeters. And you'll notice what happened. So red is indicating that it's doing a cut. Over in our extrude at the bottom where it says operation, it says cut. We want this to be joined, but we also want it to come towards us, not away. So we're going to do negative 40, and there we go. Great. So now we've got the frame of our letter, and then we're going to do a couple more extrusions. You might remember we wanted to create a little step for the insert to sit on. Okay, so here we're going to zoom way in, and we're going to make sure that we get the little, our 0.12 offset and the other offset, because we want both of them. So we want the little tolerance offset that we had made, and we also want the edge, if you will, offset. So I'm going to zoom way in here, and I'm going to get both of these. Okay, so you can kind of see what I have here. I can turn off my body here so you can see better what we're selecting. Okay, I'm going to turn the body back on, and again we're going to hit the E key, and we want to make sure that this is joined, and we're going to do a distance of 40 minus 10. So we have a 40 millimeter depth, and we're going to basically make our insert 10 millimeters shorter. So we're going to do minus 30. That sounded way more complicated than it was. And now if I turn off my sketches, you can see, there we go. We got our shelf in there. Great. Okay, we're almost done with the B. The next step is to offset our insert. Okay, so we're going to turn on our sketches again. I'm actually going to hide the body for the moment. I'm going to select almost all of the inside of our sketch here. And you notice I'm getting the tolerance piece, our edge. Okay. There we go. And you know what? Actually, I just realized something, and we can always change this. Oh, I missed this. Let's see here. This is where I always get a little. Let me turn my body back on here and make sure I'm getting the right pieces. Okay, right. So this is where we actually don't want to get this outer tolerance, because we want our piece to fit in here nicely, and the same for this. So it's kind of the opposite of what we just selected. Okay, there we go. Is that right? Nope, nope. I'm doing it backwards again. I'm sorry. Okay, there we go. Right, like that. I had my brain turned off for a moment. Okay, so let's turn this body back on and let's hit the E key. So you might be wondering, well, how are we going to get this offset out to here? Because we kind of want it to start from where this little step is. There's a couple things you can do. When you do an extrude, you can choose to do it what's called as a profile plane, which is what we're doing right now. That's just going to straight up extrude it from where it is. The other thing that you can do is you can choose to offset it. So this is going to allow you to offset it a certain amount. So we could do something like -30, and you'll notice that it moved it. And let me change this to new body down here, not cut. So now what it did is it started it. And if I turn off my outer body here, you can see it started it from 30 millimeters away, which is basically what we want. Or you can do another one, which is object. So if we turn on our other body, we can select this little step here, right there. And now it's going to start the extrusion from that place. So now what we can do is we can say -10. And you can see if we did that, it would fill this all the way in. And I'm just doing this to show you what's happening here, but we don't want to do that. We just want it to be a 1 millimeter thick. So we're going to do -1. One of the things to consider when working with light boxes is the thickness that we're giving it right now is actually what is going to determine how much light comes through, because this is the flat portion of the face of our insert. If it's a white filament color, like an opaque white, 1 millimeter is usually good. If it's anything dark, like blue or green or even a red, I tend to go on the thinner side of something around 0.6. And I'll let you use your own judgment there, but that's just what I have found to work really well to get even lighting. So let's say that we had like a B that was a white and an O that was a red. The B, we would probably leave it a 1 millimeter thickness, but we'd make the red one thinner. And that's how you can get more even distribution of light. Okay, so we'll just hit OK. And now we have another body. And if we turn on our frame there, we can see our insert. So at this point, I'm going to show you a little trick. Let's say that you wanted to see a cutaway of the geometry here, because right now we kind of have a hard time, seeing if our insert is meshing up with our frame properly. So we can go up to the Inspect menu, go down to Section Analysis, and you can see here that I have now a section analysis that is showing the cutaway. Now, I had already done this previously, that's why mine just kind of popped on. In your case, let me cancel this. Let me go up here and let's turn on section analysis. And I'm going to go right click, edit. When you first do a section analysis, it's going to ask you which plane you want to place it on. Let me see if I can just delete this. Yeah, let's delete it. Let me start over here. Let's go inspect, section analysis. Okay, here you go. So it's going to ask you which origin plane you want to slice it on. I'm going to slice it horizontally, and now I can move this up and down. You can see what it's doing is it's creating this cutaway so that we can see inside of our geometry, which is awesome because we can make sure that our different pieces aren't overlapping, and then there you can see our little tolerance. So this is great. So I'm just going to hit OK. this shows up in your outliner on the left, and I'm just going to hide it for now. So anytime you turn it on, it's going to show you that analysis. And if you want to change it, you can right click, edit, and then you can move it around. And you can add a number of these. You can add them for horizontal, vertical. You can have more than one section analyses going on. Okay, the last thing we need to do is let's give our insert the edge. You know, if we go back and look at the model that I was sharing before, you can see that it's got this nice edge to it. Okay, so let's go and add that. And the way that we're going to do this is you can hide your body. We're just going to grab the edge that we had. Whoops, I swung it around here. We're just going to grab the edge. And the negative ones, the same thing. We're going to grab this and this. So we only have the edges. I'm not grabbing the little tolerance gap. It's just the edge. And I'm going to turn our body back on. And I'm going to hit the E key to extrude. And once again, we're going to use object. And I'm going to click this face. And then I'm going to use a distance of 10 millimeters. But remember, we're going to need this to be negative. And I'm going to hit the enter key. Now, if you're following the math here, you're probably going to notice that, well, we had offset it 10 millimeters from a face that was offset 30 millimeters. So now we've actually got a millimeter of excess. That's no problem. We're going to go back into our offset here, and we're going to change this to 9. And there we go. There's our inset. Okay, so if you got to this point, great, because this is pretty much what you're going to do for the rest of your objects. You're going to create those offsets for every other object, and then you are going to do the extrusions. So we've got our B here, but I wanted to show you a couple things. Let's say that, and this is kind of artistic interpretation. Also, side note, I'm going to turn my layout grid off. Sorry, it's getting chopped off, but you can see if I click this menu down here on the bottom of the screen, layout grid, we can hide that. You'll notice that I chose to do kind of this, I don't know what you would call it. It's like a negative offset or whatever. So like the frame, or I'm sorry, my insert, the, I guess you could say like the back of it is closer to the letter and the frame is coming towards us. So if I flip it around and look at the back, if you wanted it to be where your edge or whatever is kind of hidden and it's not exposed, it's a pretty easy fix here. So let's say, for example, that you wanted your edge to be on the other side, and you didn't want the face to be inset. You wanted the face to be flush with the frame. So we can easily make that change with our history timeline here. So if you click on the timeline on the bottom, you'll see it's really smart about trying to highlight the areas that were being manipulated along this timeline. So one of the things we'd have to change is we'd have to change this first extrusion. And we'll also have to change the next extrusion. But very simply put, what we'll do then is, instead of before where we had offset the, I guess we called this like the back of our insert, remember that we have a depth of 40 millimeters and we did this an offset of 30 so that we had a 10 millimeter gap here. So instead, as you can imagine, what we do is we just push it all the way to the edge. I'm using some user data here now. I've kind of updated my design, which I'll show you all of what this means in a moment. But what I'm going to do is basically go back to making this all the way to the edge, which in your case would just be, here, I'll put in the actual math. It would just be, I think it was minus, you'd probably have to do minus 39 millimeters. Let's see, 39. Okay, there we go. Let's hit OK. And now let's turn off our back here, and there you can see we've basically just moved that the face, the main face that I'm highlighting right now, from the back to the front, so that now when your letter is facing you, it looks nice and flush. You could even have this front piece stick out a little more if you wanted. It's just a matter of how much you create your extrusions. So anyways, I just wanted to share that with you because it's just as easy as changing some of your extrusion values and your offset values to change how this behaves. So I'm going to hit Command Z because I kind of prefer this inset look. It's kind of fun, gives it kind of more of a dimensional appearance. Okay, so now I'm going to just briefly touch on user data. I'm not going to go into this in depth, and if you are not concerned with user data, go ahead and skip forward. All right, you might remember that when we initially set up our sketch, we had typed in all these values for our frame width, for the tolerance, for our edge here, and now that we're about to go and do this to all these other letters, what happens if we decide, well, you know what, I want my frame to be 10 millimeters. I don't want it to be 8. You'd have to go and click each instance that you have done an offset and update it. For example, I'm going to hit the O key while I'm in here because we're going to do this anyways, and I'm going to offset my O here, and I'm going to give it 8 millimeters. And then we'll offset the inside, give it 8 millimeters. Okay, and let's say finish sketch. So let's go up to user data here. The way that you access user data is you got to be on the solid tab and you hit this FX button and it says change parameters. So I'm going to close up the ones that I've made, but if we go down here to the Boom V1 and you start looking at some of these, you'll notice that Fusion is keeping track of all of these values and it's associating a name to them. You see here D32, D33, etc. You can actually use these values in your designs. And another way to see what that value is, let's go over here. I'm going to double click on this 8 millimeter and you'll see here D54, dimension value. I'm going to hit escape. What if I go over here and I hit on this, let me go click this 1.25 for just the fun of it here. It says D37, okay? So what do you think would happen if I put D37 in here? Well, I'll show you. So if we go in here and I type in D37, it recognizes that as a value. So basically, if I was to change this value right here, which is D37, the other value will update as well because it's driving this value. And that's cool and all, but what's even better is if you define your own values to make it easier. You'll notice over here, this says FX 8, whereas the O just says 8. And that's because I have defined a user data parameter to give this value on the left. And I called it, if I type in frame and I hit the enter key, you'll notice that it didn't change, but it's because it's an 8 millimeter offset, but now it's prefixed with FX, which is telling us that that's being driven by a user parameter. So if I open up my user parameter section here, you'll notice I've defined some things. I've defined the frame, the insert rim, the tolerance, all of what we did before, except for all I did was come in here, hit the plus button, give it a name, like whatever you want to call it, and then give it a value. And these values can also have math in them. So you can go really, really far with this. I'm just using this in a very rudimentary sense to store some of my values. But anyways, you'll notice here the frame is 8 millimeters. Well, I kind of decided I actually want it to be 10. So I'm going to hit 10, and I'm going to hit OK. And you'll notice, look at that, it updated. Anywhere where I used that frame value, it updated. And even better, look at that, it updated the geometry as well. This is now a 10 millimeter offset on the frame. So this is where user data can come in really handy, and I urge you to kind of play with it as you work through your designs, because it can make them more modular and it can make it a lot easier to make changes down the road. Like say you wanted to print one of these and you wanted the frame to be, I don't know, 15 millimeters and you wanted another one to be only 6 millimeters. Well, instead of having to go and like update every single value of the offset that you've made, you can just use user parameters. All right, so let's do another letter here, and I'm going to show you how we're going to create kind of like this join, because we want these letters again to be printed in separate pieces and we want them to snug up against each other. So we still need to do the tolerance and our frame. I'm sorry, not the frame, but the tolerance and the rim. I don't really remember what I was calling it, but the edge, the rim, etc. for the insert. So you might remember that this was it was 1.25, but I have created a user parameter for that as well. But you know what? I'm just gonna type it. I'm not gonna use the user parameter. So oops, I think I hit 125. So we're gonna say 1.25. We're going to offset this 1.25, and then remember we need to do our tolerance, which is 1.13, offset 1.13. Okay, and now we're going to do finish sketch, and let's create our O. And this is going to give us an opportunity to see a couple things in action. One of which is it's probably going to try and automatically join itself with this other body that we've already created, and it's because it's pressed right up against it. So let's go ahead and grab, remember our first step is to create the back, the same as we did with the B. So we need to select all of the geometry here. We're going to get this piece as well. We want to get all the way in here and get these, make sure that we get all of this. Okay. And that looks good. E to extrude, and we're going to do 1. Now you'll notice, look at this. The operation is join, and if we leave that, what's going to happen is it's going to combine that with this B frame, and it's because it's touching. It's close enough to where Fusion thinks that we want to join it. We don't want to do that. We want to create a new body, and then we'll hit OK. And you'll notice we've now got a new separate body here, which is what we want. And if we kind of take a look from the top, you can see that it's the same thickness that we had originally created. Now, you could create user parameters for this as well. But again, like I was mentioning before, if you're going to have different values and maybe you're using different colors, it might be easier to just leave them without it. So we can actually turn off our first letter if we want, so that we can kind of take a look at what we've got here. Okay, so now let's go ahead and do our frame. So we're going to select the outermost part, and we're going to do the same thing for the inside of the O, and then we're going to hit the E key. And this was, I had used user data here, but you might remember that this was 40 millimeters. So what we're going to do is we're going to say minus, and I'm just going to use frame for mine because I had already created that. Oh, whoops, you know what? That's not right. It was depth, frame depth. Okay, so there we go. We have our next extrusion. And while I'm doing this, because I don't think I had updated it before, and now I'm going to give you an opportunity to see another thing where you can easily mess stuff up. I'm going to go back and edit the first B because I had used a hard-coded value. I want to edit mine to use the user parameter. So I'm going to say minus depth. And if I hit OK right now, okay, actually, you know what? I think actually at the last Fusion update, it might have changed some things, because previously what could happen when I made this change is it can accidentally join this other body because it was touching it as well, and it didn't do that, which is great. For some reason in the past I remember that happening, so just be aware of that when you're editing extrusions and there are bodies that are actually touching. It can sometimes join them. So a way to help that is hide any bodies that are touching and then edit the extrusion in your timeline, and then you can guarantee you're not going to accidentally join some objects, because I've had this happen where I get down the road and all of a sudden I'm like, wait a minute, the B and the O joined themselves. What on earth happened? And it's because I went to edit an extrusion. One of the things that I'm noticing here is I kind of made a boo-boo in, I think I'm going to scrub backwards. You can see we've got a little bit of a, this extrusion is on this, I think on the B is not really what I wanted. It's coming into the O. So let me step back here and let's go back to where we created our frame, right here. And sure enough, it looks like I had selected a little too much. So all I have to do is just go ahead and click on that sketch, and it's going to deselect that from my geometry. And I'm also going to have to do it for the first layer as well. So I'm going to hit OK. And just so you can see what I'm doing, let me hide the sketch real quick. You can see we've got this little piece hanging off here. And it's because all I've done so far is I've edited the frame, but now I need to also edit the base, which is this. Now I got to turn my sketch back on. So I'm just going to deselect that, and now I'm going to hit OK. Let me show you again here. So that's what I did. I just cleaned up. I had too big of a selection, and that was my fault. So now if I move this forward, you can see this is nice and snug here, and I just have to go select this piece here on the O now. Let me turn on the sketch again, and let's go back to the O's back plate right here. Double click on the timeline, and we want that piece right there. And new body, yes, that's correct. Okay, so we can kind of like toggle these on and off real quick here to make sure that, yeah, those look right. We can turn on our analysis. You can take a peek. There's no overlaps. That's good. And this is where this gets a little more challenging when you're starting to create these, you know, we're combining these letters basically, and we have sketch overlaps. But hopefully you're able to follow what's going on. And as before, our next step is to create our, oh, you know what? I'm just noticing a little discrepancy here. Oh, okay. All right. Well, it looks like I have to edit our previous extrusion one more time, because you can see there's still a little bit of a, it's sticking out, and it's because I've selected the tolerance of the O as part of the B, and this is, it's good that you're seeing this because this will probably happen. So I need to change this again. So I'm going to hide the O for the moment. I'm going to go back to, okay, our frame. And yep, I can see right here, I had selected that tolerance piece. Okay, and I'm going to have to do the same for the base. Double click on the base extrusion, get rid of that. Okay. I'll hide the sketch again so you can see it. Okay, turn this back on, turn the O back on. There we go. Now you can see here we've got a nice smooth edge. That's what we wanted. I had unfortunately, all it really was is I had created too big of a selection when I was extruding the B frame, and it was, I had accidentally selected some of the pieces of the O. But this is where parametric modeling is great. Okay, back to where we were. So I'm going to hide the B, and the reason is I don't want this next extrusion to try and accidentally join itself. So we're going to select the tolerance. Oops, sorry. We're going to select the little tolerance piece, and we're going to select our rim, because now we're going to do the our edge offset. Sorry, our edge extrusion. So I'm going to click this, make sure that we've got all the right bits. E to extrude, and then this was 30 millimeters, right? But we needed it negative. Okay, so there's our frame for our O. And don't worry that this is like sticking out like that. Doesn't really matter. If you really wanted to go in and modify the sketch, you could add a line and make this so it doesn't stick out like that, but it doesn't really matter, because what we're going to do is we're going to actually cut a hole through this, and that's where we will pass the wires. Okay. Great. So we got the B and the O. Now there's something that we can do here that will work in this model, but it won't work in all models, and it's because we have enough spacing between pieces. So remember in the beginning when, or not the beginning, but a few steps ago when we did our B insert, we can actually go back and just add selections to that to create all of our other letters, all of the other insert pieces. Now, if the inserts were actually touching, you would need to do that separately, because Fusion will try and join them. And you remember, we need to be able to extrude each one of these inserts separately. But because none of our inserts are going to be touching, this is okay. So what I mean by this is, let's go back in time. And let me turn on this guy. Okay. Let's go back to where we had done our insert. And I'm going to hide the frame. So check this out. We can just select this. Okay, so here was our, I'm basically editing our extrusion for the insert. And now I can just come in here and I can just make a selection on my O, and you'll notice it's going to give it all of the values that we had already defined before, so we don't have to like duplicate our work. And I'm just going to hit OK. And now, granted, if I had gone ahead and done all the offsets for all these other letters, we could do the same thing. So it's just a matter of your workflow, and I'm just going through this as I'm doing it for the sake of the video, but you could have done all your other offsets and come back here and edited this extrusion and just started adding, you know, your other bits to it. So now what we need to do is, I'm just going to move the timeline a little forward to see where we are. Okay, yeah, we got that. And now what we want to do is we want to edit the offset. Edit the edge. And the cool thing is you can see that it's showing us what we had selected before for our B, and we want to do the same thing for our O. So I'm just going to select these pieces, and I'm going to hit OK, and look at that. There we go. So we just added the O, and because they're not touching, they're going to be separate bodies over here in our inventory list, which is great. That's exactly what we want, because we can export these independently. And if I just scrub my timeline back forward, look at that. Now we've got our O. Now, if you wanted to, what you could do is you could start colorizing these pieces to help you. You can hit the A key, and that will bring up your color palette. And then I usually go down to plastic, and I just drag ABS to one of these. Sorry, I'm using a Wacom tablet, and for some reason Fusion does not like Wacom tablets. So I'm going to drag that right over there. You can see we gave it a white color to the insert, and as you're dragging here, you notice it's like highlighting different things. Sometimes you have to be careful because it'll try and dump it on everything, and you might not want that. And then what you could do is you could right click, duplicate, and let's change this to I don't know, whatever color you want. Maybe you're going to print the frame in like a blue or something. So we'll hit done. And now what I'm going to do is I'm going to put blue on the frame, and watch what's going to happen here. The reason this came up is because Fusion is trying to apply it to all of the bodies. We don't want that. I'm going to hit cancel. And sometimes you just have to get at the right angle so that it's not affecting every body. There we go. You just kind of have to like move your mouse around. The other thing you can do is drag it right to the layer in your bodies, which can help. Okay, so we're going to close the appearance. Looking good. Okay, so at this point, I'm gonna go ahead and do the rest, and then once this is all done, we'll walk through creating the holes to pass the wires through. All right, so I've got the whole model completed here. I've also done some organization on the left. You can add folders, they call them groups, by right-clicking on the bodies and say new group. So I could create a new group here, and I could call this frames, and then I could shift-click, and move all of my frames into frames, so I can turn the frames on and off and the inserts on and off. So this is nice for organization. I can also turn on my section analysis here, and just kind of, you can see here as I'm inspecting that everything is looking good. What we're looking for is any sort of overlaps where the frames might be overlapping one another. This does take some finessing. I had to do like a double check, triple check to make sure that all of the frames were not, you know, when I did the extrusions, to make sure that I hadn't accidentally, you know, selected the wrong piece so that all these fit together. So if I turn these off, I'll show you what's going on here. We'll go backwards here. Actually, this should be, boom, should be right there. Okay, so if I turn on and off these pieces, you can kind of see how they're going to fit together. And also what I'm looking for is to make sure that I didn't accidentally miss something, or that when I turn on the M and turn off the exclamation, that there might be some degree of overlap. All right. I think we're good here, and now we're going to make some holes to run the wires through these letters, because we need to create some cavities to run the LEDs. Generally speaking, you could use the existing sketch, but it gets a little busy. If I turn off my bodies, you can see this is our old sketch. It's going to make it a little hard to select the sketches to do the holes. So what I do as a practice is I create a new sketch. So I go new sketch, and we're going to do it on, I'm going to have to turn the bodies off here. Probably turn off that sketch too. And we're going to do it on our front plane again. And now we can turn the bodies back on. And I'm still in sketch mode. So what we're going to do is we're going to just grab the line tool, and we're just going to start making some kind of rough holes here. And these don't have to be perfect. We can always change these later. So I'm going to draw another hole here. Let's do another one. Let's see, we're going to run that up. Yeah, let's go here. And then finally, we're going to go to the eye. And we need to have a little hole here to go into the exclamation dot. All right, so we've got our sketches, and now we can kind of move these around. So hit the escape key to get out of line drawing mode. I'm going to double click on this. I'm just going to kind of move it up a little bit. Let's go over here. I'm going to double click on this guy. Something funky going on here. Whatever, I'll fix that later. Let's double click this, move that to like there. Double click this guy. I'm just going to kind of move it up a little bit. And I'm not doing anything of precision here. I'm just trying to kind of place these. And if you single click on an edge, these are still, because these don't have constraints or anything, you can totally adjust these. I'm going to hit the D key for dimension, and I'm going to click this line. Whoops. D key for dimension, click this line. I'm just curious how big that is. 15 millimeters is plenty. We got all our sketches drawn out for our LED like the strip holes that we're going to create. So here's what we're going to do. I've turned off the other sketches you can see here in the palette on the left, and I'm going to hide the bodies for just a moment. So I'm going to click on frames. What we're going to do is we're just going to select each one of these holding shift, and then we are going to turn back on the frames, and we're going to hit the E key for extrude. And we're going to grab this, and we're just going to like pull it up some degree. And I want to check a couple things. I want to make sure that when we drew our sketch that it was not punching through the bottom, which great, it's not. And that's part of why that worked out, is because initially we extruded 1 millimeter in a positive direction for the bottom. So it actually went away from us, which is good, because this new sketch that we drew was on the same plane, but we're pulling it towards us. So that's great. As far as how deep you do this, a typical LED strip is around 13 millimeters wide. So, you know, you could do like, I usually go a little extra. It's like 20 millimeters. And you can see now, here are all our holes that we can run the wires through. So if I turn these off, you can see that we've got a nice hole there, and it didn't affect our base, which is great. And we have a hole to go into the bowl of the exclamation. If I turn the M back on, you can see the same thing. Nice. The O, got another opening. And in my case, if I really wanted to be, you know, a little cleaner about this, and this is kind of what's cool about Fusion too, is I'm just going to click this line and I'm going to move it up right about there, and you can see it's just updating the geometry for us, because I wanted to make that a little snugger into this line just to be a little cleaner. And lastly, maybe we'll do the same thing here as well. We'll just kind of grab this and pull it up a teeny bit, get it a little closer to the edge. This is just going to make it easy for us to kind of wrap the LED around this corner. And then let's check out the B. Great, it's all looking good. Okay, so I always forget to mention save a lot. So I just hit Command S to save, and we're going to turn that sketch off. And we can turn on our inserts, see what we're looking like. Let's change this to visual style, shade it with hidden edges. Okay, great. Now lastly, I'm not going to be hanging mine. I'm going to be just laying it on these pieces to kind of like set it on the ground, if you will. You could punch a hole in the back to hang this. There's a lot of things you can do. What I'm going to do is I'm just going to create a hole for a cord, and I'm going to create a hole for a switch. So here's how you can sketch on top of existing bodies. So all of the sketches we've done to this point, we've kind of just been going up and creating a new sketch and then having it ask us which plane we want it on. But you can do it on bodies. So I'm going to right click, and then I'm going to go down here to create sketch because I want to just sketch on the back of this O. So I'm going to hit the, go up here, and I'm going to grab the circle, and I'm just going to draw a random circle here. 4 millimeters is usually a good enough size for a typical like USB cord diameter, which is what I'm going to be using. And then I'm also going to be using a little toggle switch to turn this on and off that I'll wire up. So I'm going to grab a rectangle and kind of up here, roughly in this area. Mine is about, let's see, I think it's 8.5 by like 13. Something like that. I'm gonna hit the enter key and I can check because I've got it on another, yeah, 13.5 by 8.5 roughly. So I'll change this to 13.5 by 8.5, and I'm just gonna kind of swap around the other side and make sure it's not gonna like hit with anything. I might want to move that up just a teeny bit. So I'm gonna double click on it, just move it up, hit finish sketch. And okay, now what we can do is we can actually use, well, we'd have to do a couple things in our timeline here, but we could use that other extrusion that we did for the all the holes for these as well. Given it's going to be a little overkill because what we extruded for the holes was something like 20 millimeters, but it doesn't really matter because it's just going to punch right through. So what we could do here is we can actually move things in our timeline. So what you might have noticed down on the timeline, I dragged the extrude, this is called extrude 17, in front or after the sketch so that the sketch appeared before in the timeline. And now what I can do is I can just double click on this extrude and I can just go ahead and let's see, can I grab that? I guess I can't do that. I was trying to be creative here and use the same the same sketch or the same extrude to extrude these two fellas, but I guess we can't do that, so it's no problem. Just select those two, E to extrude, let's go -1, and it will punch a hole for us. And there we go. So now let's take a look here. Everything's looking great. And that is pretty much it for our modeling here. So we've got our frames, we've got our inserts, we learned a little bit about section analysis, creating sketches on bodies, creating sketches on origin planes, lots of offsets here. So as you can tell, these things are, they're not the easiest to make, and maybe at some point somebody will create a automation or like a Python script where you can just give it a bit of text and then you can, you know, easily go through this process. Because I've used user parameters here, like let's change this real quick. Let's say that I wanted my my width to be 12, and look at that. It just made the frame all wider, which is really nice. And this is where user parameters can be really helpful. If I change this back to 10, you watch in the background, the bodies will update. All right, so let's export these. There's a couple of ways you can export bodies from Fusion 360. You could select the body itself, right click, save as a mesh, and that will save it to your desktop. But you can also save this whole thing out as a 3MF file, which makes it really helpful when you're working with multi-part assemblies inside of a slicer. So what we're going to do is we're going to go up to Utilities, and I'm going to click Make, and it's this like 3D print button. You'll notice that OK is grayed out, and it might be kind of confusing why that is. Well, Fusion wants you to select whatever parentmost folder or individual folder you want the bodies to be. You know, you have to select some bodies, if you will. So I'm going to say 3MF, and you could send this directly to a 3D printer. For the sake of this, I'm just going to send it to my desktop. Don't mind this warning. And I'm just going to, call it Boom V6, save it to my desktop, and out it goes to the desktop. Okay, let's jump into Bambu Studio. And now what I'm gonna do is, you can't see this, but it's just sitting on my desktop. I'm just gonna drag the 3MF in here. I could also double click it to open it in my slicer. And it's just saying, hey, this is several objects, etc., etc. Should the file be loaded as a single object with multiple parts? Yes, that's what we want. And right when it comes in here, it's humongous, as expected. If we go over here on the left, you'll see here that we have all these bits and pieces that came as part of this 3MF. What I'm going to actually do here, just because it makes it a bit easier, and we don't want these to be parts, we want them to actually be split into objects. So I'm going to go split into objects, and now these are all like individual pieces that we can move around, which is exactly what we want, because we want to split this up onto a couple plates. So if we just hit arrange right now, see it's going to try and arrange all of these onto a single plate. And I just realized what I probably should have done here, I'm going to step back, is first and foremost, let's go back to where it was a single piece, and let's orient it flat. And now I'm going to right click and we'll go split into objects. Cool. And let's add a couple plates here. So I just hit plus in the upper toolbar here that says add plate, and let's just move some of these characters around here and start trying to figure out what we're going to do here for each one of our build plates. So we can probably fit the B. Oh, did I just notice something here? Hold on here. Let me click on this plate. Nope, it's okay. Never mind. I thought I saw something that I screwed up. All right, so the B and the O might not fit on the same plate, but the B and the exclamation definitely will. So while on this plate, I'm going to hit arrange right here, get those two arranged together. I'm going to drag off these inserts. Drag that insert off, insert off. Okay, so we've got this O. Let's see, will the two O's fit together? Yeah, they'll probably fit together, but maybe we should go like this. Let's click this. We gotta, so if you're gonna arrange, you gotta click the plate first, or otherwise it has a tendency to try and arrange everything. Okay, that's looking good. We got the M on its own plate. Let's create another plate, and we'll put some of our inserts on here. I'm just gonna rotate this by hitting the R key, and we'll put, let's put the B. Will the B fit? Negative. Okay, let's put our exclamation on here. We'll arrange that. Let's do another plate. Let's put the O's on that plate. We can arrange that. And then one more plate for our B. Okay. What I'm going to do is we know that these are going to need supports. So I'm going to go to the global toggle in the left palette. We're going to go over to support, enable support. We're going to go tree auto, and I'm going to do tree slim. And if we go to the first plate and we slice it, we can see that there we go. Got our supports in there for our LED pass-throughs. Great. Let's go back to prepare. So realistically, all of these, I'm just gonna command click, and I'm gonna press number 1, because that would be my black filament. And let's say that, I don't know, maybe you wanted your inserts to be orange. Sure, why not? We could just leave those as is. As far as resolution goes, generally, I actually print the frames at a pretty high layer height. And so if you wanted to create, one big file like we're doing here in Bambu Studio, which is kind of unique in the sense that you can do a big batch setup like this, which is really nice, I would want the layer heights to be different for the inserts than I would for the frames. So the way we do this is you go into objects, and if we select all of our frames by holding the command or control key, and then down here in the bottom, if we go to strength, Let's see here. Quality. Yeah, I'm sorry, quality. And for a 0.4 millimeter nozzle, I think it is 0.2, 0.24, 0.28. So I'll do 0.28 layer height for those. And then everything else will get 0.2 millimeter because that's what the default is. So if I click on this exclamation over here and then I go back to my quality, oh, interesting. It should have been 0.28. I wonder why that didn't take. Oh, you know what? I must have accidentally not clicked that one. So anyways, this is how you can do, I guess you could say like object by object overrides, where we want these to have a higher layer height and we want these down here to stay at 0.2 millimeter. Well, that is basically it. Now you could go ahead and fire these off, and then you would basically glue the frames together and then put the inserts in. We will have a follow-up video going through that piece coming soon. But thank you for watching. I hope you learned a bit here, and hopefully it wasn't too confusing. These text-based light boxes can be a little challenging in Fusion 360 because you have to do multiple offsets to take into account the tolerances and creating the shelf for the inserts to fit in and so on and so forth. But the finished product is pretty rewarding and pretty impressive. They look very professional. So thanks again, and we will see you soon.